Okay, so I'm just gonna briefly talk about what portion you might want to do. So I will cover like the initial problem statement and data preparation, explaining the data set, and also the design decision for the models. I think basically I'm gonna cover everything uh, up until here, right? And then you can just go over all these sections, just like briefly talk about the visualizations. I think there's a section with visualization, yeah, like these things. Um, and also, okay, so I'm going to cover up until 5.5, the ranking metrics. And you can start from 5.6. So this is just a bunch of auto ML or Mueller loop setup, however you like to call it, with the uh, with the output. Okay. So the main thing to demo on your end is like you can talk about the master results here. And what else? The visualization and the feature importance here. And for the demo, there's a Grady.io thing uh, I created in the end. Now, you do not, I don't think you need to run the entire project. You can, like when you open the notebook, you can just scroll down to the bottom and just fire up the last section of the Grad.io, and then you can just go into the link and do the demo. So this is a very simplistic demo, right? We're just very simplistic front end. If you want to make it uh, more fancy, you can. Remember last semester we were doing that job posting recommender. You made a LLM friendly front end, so you could do that, but right now it's just like a simple query request. There are three types of queries you can do. One is query by zip code. You can just input a bunch of zip code in here. And one is query by region. So there are multiple regions, and then you can just select one of them and it will return a top 10 list of zip code with some of the metrics, right? The raw score, the ranking, and the percentiles. And also you can query by state. So this is equivalent as asking, okay, give me what are the top 10 most suitable zip code to build a data center in a certain state, right? I can do this. But I want to do the zip code query. Like I want you to do this uh, with some interesting input. So if you come back here, there is a section where I have the true positives. So this is the collection of data of zip code that actually has a data center, right? I shared this Google Sheets file with you. Remember, we both worked on this. So we gathered AWS, Microsoft, and Meta and Google, all the current data center locations, and we collect a set of zip code. This will be this true positive set, right? Uh, so you might want to pick some of this zip code and test it out and see what the ranking gives you, right? For example, I might want to do this, right? Pick one of the true positives. Sorry, no, this is not, pick one from here, right? For example, this one, right? I want to. So with zip code, you can do multiple ones. You can just space or comma separate them. So th this is one of the things that you should test. for zip code. That is one of the true positive zip code. The other one is a negative set, which is basically the most expensive zip code or metro centers, right? Like downtown LA or downtown Manhattan. So ideally, we want to see relatively low ranking, low score for this negative zip code because you're not going to build a data center in the heart of Times Square, right? So let's say I pick a zip code from LA, come back here, paste them, something from Miami, right here. Um, yeah, and New York, most expensive ones. It could have, Palo Alto or something. Right. So when you do the demo, make sure you open this file and just briefly talk about what this spreadsheet was containing. It basically contained three sets of supposedly negative data samples and all the positive ones. I will also talk about this file in my portion of the demo, but when you do the live demo, you have to use meaningful zip code. So for demonstration to show that our prediction model actually uh, can pick up both positive and negative ones. Okay. So, and also it should be able to handle things like invalid input, right? So this one is an invalid input. So it should give meaningful error messages. So let's see how it goes. Okay, so it gives the response for the valid ones and also says this one is an invalid zip code. So yeah, so for the demo, you could do this and you can just like say, okay, so this is one of the negative examples from downtown LA, and indeed it has a very low score, very low ranking, right? Versus this one is picked up from our positive examples, right? This is picked up from here. So this is the positive set, the true set, which contain actual data center. So for this one, it has one Microsoft data center. The top one has 66 AWS and all that. So yeah, when you do the demo, just make an interesting testing case for this one, and just like demonstrate, oh, our model can actually successfully place positive example at the top of the ranking and like extremely low or negative example at the relatively low ranking, right? You can see Miami, New York, and even I think this is a very famous location in the Bay Area that hosts rich people like Apple CEOs and Meta CEOs. They all live here, so it makes sense that they receive a low ranking. Anyway, so that's so much for the demo on your part, and then you can just go to the IEEE document, IEEE paper, and also just like spend a minute talk about that paper. So that should pretty much be your portion of the video. I'm going to make my portion of the video, and we can just like upload them and merge them into one. I'm not sure if you have a video editing software. If you don't have it, you can just send me your copy. I can merge them on our end and upload on my end. I'll upload them. Okay. Yeah, that's it.